Greetings, everybody. In this video, we're going to talk about two important concepts in counting. We're going to talk about combinations and permutations. Now, these rely on a concept called factorial. So if you're not familiar with that, make sure you familiarize yourself with that first. I have a video on that, so you could watch that video. Okay? But let's get started. Let's think about how combinations and permutations work. Okay, so here we have an example where we have four marbles of four different colors, green, yellow, blue, and orange. All right. So the first thing we want to talk about is the number of ways we can select two marbles from this group of four. All right. So the first choice, our first marble, there are four possibilities, right? Orange, blue, yellow, or green. For the second choice, for a second marble, there are three possibilities remaining. So each one of these branches gives us an answer to our question, a possible choice, right? I could have chosen orange and green, orange, blue, orange, yellow. So 1, 2, 3, and then we have 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12 total possibilities. Now, we are keeping track of order here. Orange, then green, we are counting separately from green, then orange. This is the number of permutations. Permutations counts the number of ways you can choose k things from n things where order matters. So the same group, but with a different order, we count differently. And the formula to do this, and just like we did here, how did we compute this? We took the number of choices for the first marble, there was 4, times the number of choices for the second marble, 3. 4 times 3 gave us the answer. In general, how is this going to work? Well, it's going to be the number of choices for the first object. So if you have n objects, it's going to be n. And the number of choices for the second object, n minus 1. Number of choices for the third object, n minus 2. And we keep multiplying down until we get down to n minus k plus 1. All right? And that's exactly what we did with the four marbles here. We're choosing 2, so I counted down to 3. I did 4 times 3. So I counted from 4 down to 4 minus 2 plus 1. That's 3. Right? So another way to write this down is using factorial. So the number of permutations of n things taken k at a time is n factorial divided by n minus k factorial. That gives us the exact same thing. So that's a nice handy formula to remember. Okay, so the next idea is to talk about what if order doesn't matter. And this is where combinations comes into play. Combinations count the number of ways to take k things from n things when order doesn't matter. And this is very commonly the case. If I'm choosing marbles, I may not care about what order I got them in. I just care that I got a blue and an orange marble. I don't care which one I got first, right? So if I want to count things this way, let's think about how we do that. Well, I'd go about it this. I'd start the same way. I'd say, how many ways can I choose my first marble? 1, 2, 3, 4. How many ways can I choose my second marble? Well, for each choice, first choice, I have 3 choices for my second one. Okay, so 4 times 3. But what have I done? I've counted some things twice. Here we have an orange, then a green marble. We got an orange and a green. But over here, we had an orange and a green. I just chose them in different orders. So if I count 12, I've counted this pair, orange-green, twice. I've counted it too many times. So we need to compensate. We need to correct for this overcounting. So we have to divide, to make this correction, we have to divide by the number of times we overcounted. Well, how many times did we overcount? Well, that is equal to the number of ways we could have arranged those two marbles. We're choosing 2 marbles, so there's the number of ways we can arrange 2 things is 2. It's actually 2 factorial. So we have to divide by 2 factorial. So we take our number of permutations and we divide by 2 factorial, divide by 2, we get 6. So there's 6 possible ways when order doesn't matter. And the general formula for this is to take the same formula for permutations, which is n factorial divided by n minus k factorial, but then divide also by k factorial to make that correction factor. So this is the number of ways we take k things from n things when order does not matter, and that is a combination. So we've talked about 2 things here. Permutations, when order does matter, and combinations when order doesn't matter.